All right. In this video, what I'm going to do is go over the example 5 and example 6 from 11.2. So we have this system of equations here, and then we're asked to solve it using matrices. So what we're going to do is we're first going to put that into a matrix. So the augmented matrix that represents this situation is shown here. Just a reminder that you're just using the coefficients and that you have, each column in the matrix represents a variable. So like this is x, this is y, this is z, and then this would be your constant, right? So that's the first step. Now, what we want to do is we want to get this into simplified form, row echelon form. So what I need to do is I need ones across the diagonal, and I need zeros underneath those. And then ideally, the rest of these turn into zeros as well. So let me just go ahead and zoom in here and give this a shot. So I want to encourage you to refresh your memory on the rules that are possible. Remember that we can multiply any row by a non-zero multiple, including fractional multiples. So, if I needed to divide by 2, this is the same thing as multiplying by a half. And then you could swap any two rows. That's another rule that you can use within matrices. And then the third thing is that you could multiply any row by some non-zero multiple and then add it to any other row, okay, in order to create a new row. So we're just going to mix those operations in here and try to solve this matrix. So since I already have a 1 in my place here, I want to eliminate that 2 and get it to be a 0. That's my first step. Okay, so I'm always shooting to get rid of, to make that a 1 and then these zeros. So I want those 2 to be zeros, and since I have a 1 in the middle there, I want this to be a 0. So that's what I'm going to be working on here. All right, so let's do that. So I like to write out what I'm doing in order to make that happen. So looks like one easy thing I could do here is I could say, okay, I want my new row 2 to equal, you could do negative 2 times row 1 plus row 2. Okay, so if you do that, I'm only going to focus here on the middle row. Negative 2 times row 1, well, that's negative 2 times 1 in this case, so that's negative 2 plus row 2, which is 2. That gives you a 0. And then in the middle here, we have negative 2 times negative 2, which is 4, plus row 1, which is 1, so that would be 5. And I know I messed that 1 up, so we're going to have to fix that later. And then for the third part here, we have negative 2 times 3, which is negative 6. Negative 6 plus 1 is negative 5. And then we have negative 2 times 7, which is negative 14. Negative 14 plus 4, which is negative 10. Well, it looks like 5 goes into each one of those nicely, so that'll help here. But let's see if I can get a 0 on row 3 as well, since we're messing around here. So let's see if we can do that. So I would do kind of the same process. I think I would go 3 times row 1, right? Because I'm just trying to focus on this guy right now. So 3 times row 1 plus row 2. Okay, so if I do 3 times row 1 plus row 2, I get 3 times 1, which is 3. 3 plus negative 3 is 0. That's what I was trying to do. And then 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4. And then 3 times 3 is 9, plus negative 2 is 7. And then 3 times 7 is 21, plus negative 10 is negative 11. Ooh, did I say negative? I think I mean positive. 3 times 7 is 21, yeah, so positive 11. Okay, so I made that a 0 as well. I'll keep my first kind of row here the same. And now I have a brand new matrix that I'm looking at. Okay, so that's my new matrix that I'm going to use as kind of a key. And now my next goal is, well, I kind of want these to be the middle row here. Since 5 goes into everything nicely, I might as well turn all that into 1s. Okay, so I'm going to divide everything by 5 in that middle row. I'm going to use my eraser function here. So if I divide this by 5, this by 5, 5 divided by 5 is 1, 5 divided by negative 5 is negative 1, and negative 10 divided by 5 is negative 2. So I'm going to just make this a negative 2. There we go, so that looks a lot cleaner. And now I'm going to focus on getting this guy to be a 0. Okay, so how do I make that a 0? Well, there's a couple of things I could do. I could multiply by a row and then add it back, which looks pretty good right now. So I think what I'll do is multiply. I can multiply let's multiply the middle row. Let's see what happens if I multiply the middle row by 4 and add it back. Okay, so if I do that, I'm going to just zoom in here and try to make a smaller matrix here. Hopefully you can see this okay. Okay, so if I go middle row times 4, I'm going to say row 3 is equal to 4 times row 2 plus row 3. Okay, well 4 times row 2 that's going to be 0, 0 plus 0 is 0. 4 times 1 is 4, 4 plus negative 4 is 0. Alright, then 4 times negative 1 is negative 4, negative 4 plus 7 is 3. Alright, and then I'm going to take 4 times negative 2, which is negative 8. Negative 8 plus 11 is 3. Alright, so now what I have is I have a 3 in both places here, which is nice. Okay, this is in the z column. If I divide both of these by 3, okay, if I divide row 3 now by 3, it'll just stay 0, 0, and then it'll turn into 1 and then 1. Right, so I'm going to divide by 3 and turn these into 1s. It's the same thing as multiplying by a third, so I can do that. So now that last row there is exactly what I want. And then in the middle here I still have 0, 1, negative 2, and then I have 1, negative 2, 3, 7. Okay, so that's my new matrix. So what I'm going to do is I'm going to erase my old one here. Alright, and then we'll go back to that. So you're always working on from your previous matrix using matrix operations to get to your next one. Okay, so now what I need to do is I need to get some more zeros in here, right? So what I can do is it looks like what a nice thing I could do is remember I can add any two of these rows together too. If I were to add, by the way, I know z is equal to 1. Right, because this is my z column, this has a 1. Once this is a 1 with all zeros, I know that this is the solution there, so that z is equal to 1. Okay, so let's do this. Let's see if I can replace row 2 using the operation of adding 2 rows together. So let's just say that for row 2, let's try this, I say row 2 is equal to row 3 plus row 2. Okay, so if I do that, I would get 0 here, right? And then for the next one, 0 plus 1 is 1. So that stays the same, which is what I want. And then I have 1 plus negative 1, which is 0. That's exactly what I want. And then 1 plus negative 2 is negative 1. Okay, so what I've just done by doing that operation is solved for my y value. That's in the y column, so now I have y is equal to negative 1. Okay, so we're almost done, so sit tight here. So the last one here is what can I do to row 1 to get these guys to be zeros? Notice that's what I'm working on last here in this matrix. There's a pattern to what I'm doing. So one way that I can do that is, and what I'm going to do here is just make this my new matrix so I don't confuse anything here. 0, negative 1. All right. So what can I do to that first row? I don't want to mess with this 1, so hopefully I can keep that a 1. But if I multiply row 2 or row 3, and I'm going to go with row 3 here, I think. If I multiply by row 3 and then add back to row 1, that doesn't help me because that leaves me with that -2 still. If I multiplied row 2 by 2 and add back, that may work. Okay, so let's try that. So let's try what happens if row 1 is equal to 2 times row 2 plus row 1. Okay, well for the first one we have 2 times 0 plus 1, which is 1, so that works. And then for the second spot there we have 2 times 1, which is 2. 2 plus -2 is 0, so that works nicely. And then I have 2 times 0, which is 0, 0 plus 3, which is 3. And then here I have 2 times -1, which is -2. -2 plus 7 is 5. Okay. So I've almost completed this thing now. All right, so just making sure here that I did this correct. 2 times 3, 2 times 0 plus 3, 2 times -1 is -2 plus 5, which is plus 7 is 5. Okay, good. So now I just need to get this to be a 0, right? So one way I could do that is I can multiply row 3 by 3 and then add it back. Okay, so if I do that, so now I'm going to go back to my new, that's my new matrix. Okay, so now I'm going to go back in my other matrix. I want to keep the same, but I'm going to erase this first row. Okay, so what I want to do for this first row here, I want to say, okay, row 1 has to be equal to, since I'm trying to modify this guy here and make that a 0 without messing with the rest of it, since these are zeros, if I'm multiplying by those, it's not going to modify anything above that, right? So I want to focus on this row, this last row here. Since this is a 1, I can use that as a key to get rid of that 3. Okay, so what I could say is I want row 1 to equal -3 times row 3 plus row 1. So if I do that again, this is not going to modify anything in the first few here, right? Because -3 times 0 is just 0 plus 1, which is 1. And then this would be a 0. And then here I would have -3 times 1. -3 times 1 is -3. -3 plus 3 is 0. And then over here I have -3 times 1. Again, -3 times 1 is -3. -3 plus 5 is 2. Okay, so now I've solved the matrix. We're in reduced row echelon form. I have x is equal to 2, y is equal to -1, z is equal to 1. Therefore, my coordinate is 2, -1, comma 1. Okay, so that's how you do that one. Now, I was going to do example 6 as well in this video. I don't want this video to be too long. Example 6 is not much different. In fact, it's probably a little bit easier. So I think I'm just going to leave that one alone, let you work that one out and try it out. But again, here's the strategy. Get these to be zeros first, okay? And remember, you can swap any row too if you need to, so if you get a different one to be 0, that's okay. But try to get a 1 there and get these to be zeros first. Once those are zeros, then you have 1 across the diagonal, then focus on these other ones. All right, that's the strategy I'll give you for that. And that's it. There's a couple things else that that I would like to talk about in class that I didn't put on your notes. One of those being what happens here when you get a row of zeros. Okay, so if you get a row of zeros like this, that just means that everything got eliminated in one of the rows, right? So when that happens, what I like to do is I like to just turn it back into equation form, which I think is what they do here too. So you'll notice what they did was they took this and they turned that into equation form and then solved, right? So they used a substitution there, it looks like, and then solved. That's totally valid, and you could do that. I would encourage you to do that actually if you get all zeros, is just turn it back into equation form and then solve, see what's left. So they had a couple of those and a couple of those ones where you get no solution. because when you reduce it down, you get like something like 0 equals 10 or something like that. So there's a couple like that you might run into. Like this one here, looks like you have 0 equals negative 27 because this 1 right here got eliminated, right? And there was no way to avoid it. So when you get a 0 equals negative 27, you know that that's a no solution there. Okay, so that's an inconsistent system. And the last one they did was looks like they did a row, 4 rows, but notice there's only 3 variables. So if this happens to you, you'll know that one of the rows is going to have to go to all zeros, okay, because there's only 3 variables. So, yep, looks like they did that here, right? So if you get the last row to all go to zeros on one like this, that's what you need to have happen, because again, you only have 3 variables, right? So you only want 3 rows. So you'd only want a 1 here, here, and here, and then the rest of it to be zeros. So they show kind of that thing. And I'll post these notes so you can kind of scroll through these and look at these. But that's it for now.